Welcome, everybody. This is going to be the fifth episode in the series for the NSA Codebreakers 2024 challenge. And in this one, we're going to be looking at the Task 5 Follow the Data Part 1, which has reverse engineering and forensics skills. In the last challenge, we had gone through and decrypted an encrypted share using the crypt setup script and a brute force method, and we're able to identify that our ID was a UID and could successfully decrypt the image and came across some new files. This is recorded shortly right after that one. All that has happened since then is I installed Ghidra onto the system. In fact, I'll have to install Jeff as well. And I can just do that right now while we're talking or going over the challenge. So if you don't know what Jeff is, it's a pretty much GDB front end to make everything look and handle nicer. So with that running, come back over to the challenge. So let's go over the description and see what we're looking for. So based on the recovered hardware, the device seems to have an LTE modem and SIM card implying it connects to a GSM telecommunications network. It probably exfiltrates data using this network. Now that you can analyze the entire firmware image, determine where the device is sending data. So we need to analyze the firmware files and determine the IP address of the system where the device is sending data. All we need to do is enter the IP address and it doesn't want us to guess. Let's make sure that Jeff was installed. You can tell it was just by the fact that now we have a Jeff prompt instead of a GDB prompt when we run GDB. So if we remember, after decrypting the share and mounting it, we came across several new files. Let me go back to the start script, which was in SD etc. Change to etc initd cat this one. So we can see here that after we're decrypted into agent, we're now going to run agent start. So if we look over here, we have this new start file. So that's probably the best bet on what's going to be ran. Before we start, I'm going to move these files to a new directory. Just close this terminal. Change to Codebreakers, make directory 5 for challenge 5. And I want to actually move a lot of these files. I'm going to do this as sudo because I had mounted this share as sudo and it won't let me even read these files, I don't think. Yeah, I don't have permission to read the files right now as this user. So let's copy 4 USB image extract and then everything into this directory. I think that was the wrong one. Agent and everything into this directory. I might just do agent. Let's do this as recursive. So now we should have this agent directory. And we have the encrypted parts, which don't matter, but we have them. I'm going to then... do I have permission to read them now? I still don't. Let's do a sudo chown as Kali for all these files. We'll do a recursive for the lost and found. I don't think that should matter. Okay, that needs to be before recursives of even argument, capital R. There we go. So now as this user, we should be able to read these files. Perfect. So let's read the start, because that's the first one. Don't need this terminal anymore. Move this one over to the side. Okay, so it's another bash script. Looks like we're in the dir agent, proc agent, restart files, agent restart. We start the navigation service. So bin nav, don't think we have that. We can look back at the bin directory. Change to 4. It's always nice to know what you're working with and what you have. And we remember that we have a bin directory here. Doesn't look like we have a nav binary. So it looks like we make a directory /temp/upload. Then we do a dmessage, just dump some time into there. Or dump the boot script or boot argument or commands or whatever. Start agent and restart if it exits. So while one, do that. Looks like if the restart file is there, then break. Or if it's not there, break. Yeah, so while the restart file doesn't exist, if it doesn't exist, so while it does exist, keep looping. If it doesn't, we're going to break. Else, if the process isn't there, and the process should be agent, then restart it, dir process, dir config, finish sleep 10. So it looks like it's just an infinite loop to make sure agent is always running. And it looks like it's going to run agent with this config, so it's a good idea to look at the config. Looks like we have a log level, we have a log directory, daemonize, argument. Looks like we're now using the IDs. So we have the id.txt, ssh private key, so this is the elliptical curve one, command host, all zeros, command port 9000. Collectors are some devices that are probably created or exist on the device. Collect enable equals true, dropper exe, so it looks like this then will somehow relate to these other two files, dropper with a YAML, which we don't have at the moment. Dropper upload is temp upload, navigation IPC, interprocess communication. So it looks like what it's going to communicate with the nav binary, if the nav binary existed. Key file, this one's new, we haven't heard anything about an HMAC key yet, and a restart flag with that. I think the only thing that hasn't been mentioned yet is this diagonal client. But if we run strings on agent and grep for diag client, we can see that it is actually going to use it. So somewhere within agent, diagonal client is used. If we run strings on diagonal client, looks like we have these variables like go and crypt. Just this kind of setup is very Go-esque. It's a programming language that's very async kind of heavy. And if you just run file, you can see that we have a ARM binary, Go builds. Yep, so it's running Go, or it's built with Go. About dropper, looks like dropper is also built to Go, and file run on agent. Agent doesn't appear to be Go, but it's still ARM, and it looks like it's statically linked and stripped. So while those aren't ideal, it is possible to reverse engineer them. Go is a little bit dicier, but we're going to try this out. This new Ghidra version that just came out 2 weeks ago as of this recording. I was on the fence as whether to use 10.4 or 11 for this video, as I've never used 11 yet. I just noticed that it came out. But 10.4 had come out like a week or so, or the day, like right around when the Codebreakers challenge started, so that's kind of the version most people would probably use for this. If you look at the 10.4 version history, it looks like they have some Go support was added. But if we look at the version history for 11, and we come down here to Golang, it looks like they've added a bunch more processes. So we're actually going to see how it looks within the new Ghidra and see how easy it is to reverse engineer. And we'll take a gander at that. Don't need that one. So yeah, if you've never used Ghidra before, you can just search Ghidra. The first one should be their page, give you getting started, but you can just go to the releases and download it. I've already installed it because I didn't want to go through the process in the video of just downloading Java and Ghidra and getting those to run. But I've just added them to my path. But we know we have 3 binaries. We're not really sure. Like, we could do strings on all of them and try and grep for an IP address. I can already tell you that it's not going to work. There's no just plain text IP addresses in here that are the correct answer. There are a couple in here, but those are just kind of default debugging or logging ones for the Go clients, I believe. And you can submit them, but they won't be right. Those will be kind of on the guessy side. You'll know for sure the correct IP address because it'll kind of be obvious when we find it. But with that said, let's just run Ghidra, and if I spell Ghidra right, Ghidra run. If you've never used Ghidra, I'll kind of give you a walkthrough. I'm not sure if I'll be able to zoom in. So we need to create a new project. Project name will just be Codebreakers. Finish. Let's open up I'm just going to do this with xtg tech open. Didn't mean to do a comma. We'll toss agent in there. Looks like it identified as an elf and arch. we're going to start analyzing this guy. We'll do this one first. All of these, it'll be very useful to reverse engineer all of them, even though all of them might not be for this challenge, as they'll be used later on. Let's analyze that, see if there's any kind of arguments we can add. Just going to see if there's any way to just analyze. Make this full screen. Can I zoom in at all? Process tools. No view. It's going to be very unfortunate if I can't zoom in for the video. Let me do a quick... what would be the best way to go about this? Can I zoom in the recording side? If I can, I don't know how. Doesn't appear so at the moment. View. Nope. So hopefully this is visible within the video. If it's not, I'll just have to redo this with a new method. There might be a magnifying glass accessibility. Probably what I want, but probably not as well. Let me do a quick search to see if we can zoom in Ghidra. Looks like there's an issue. Is there a way to increase the font size? In support launch.properties, you can try setting font size over a specific font size. Not very useful. What if I just make this really big? Just have a little bit off the window. It's a little bit better, not great though. We'll just have to do that for now. So this is Ghidra. I don't know if it identified a main. It did not, but we're in the entry. A lot of this will probably be handled within the decompilation side versus the actually assembly side. But yeah, so if we hop over here, this should be the main, I think. Let's create a function. Let's rename this function. Be nice. Oh, there it is. Rename that to main. Can I create that as a function? There we go. And we jump in. It looks like this is like the main loop of the binary. Kind of big, gross, and right now we don't have any names. If we go through all the functions, we can just see that they're all named function. So there'll be a lot of reverse engineering here. When I come across a binary like this, a technique that sometimes works is we're going to close this. We'll save. We're going to come over here. We're going to create our own binary. We're going to say test.c, just something simple. Include standard io.h, hashtag include standard lib.h, int main, and all it's going to do is just say printf hello world. Oops, why can't I write? Oh, I copied this directory, so I don't have permission to write here. 1 second, sudo chown everything in this directory, please. So let's go back to agent. Write that again. Include standard io.h, include standard lib.h, int main, printf, so do hello world, gc test.c. Okay, so it runs, but that's not what we care about, because what we want is a ARM binary, so then we can load that in beforehand, which will have symbols, because we're going to add or compile this with debug symbols. Probably not debug, just symbols. And then we can do an analysis between this one and the other binary, and then get some of the easy standard functions, since this is compiled statically, loaded right away. The way we can do this is by using the Arch64 GCC subset, which I don't remember off the top of my head. I think any of these should work. Let's just use GCC 13. Could probably figure out what version of GCC was used within, if it has it. Probably doesn't. Streams agent grep for GCC. Nope. The only reason you'd want to try and get as close as version as possible is the fact that the more closely assigned they are, the better Ghidra will be able to, the more likely that they'll compile similar functions similarly. There are different caveats, like different libc versions and different kind of libraries, but overall it should be fine. Let's grab this one. I think apt install gcc sudo apt install that. Take a little bit, but we're just going to install some cross compilation tools onto this system, so then we can better. Oh, did I accidentally close my Firefox? Whoops. We'll have to get back to that NSA page later. So do I have GCC? Do I have Arch GCC? Says I do. See if it works. 13 we'll do debug symbols, just see if it does anything. Test.c. So now if we do file on a.out, we should see that we have an ARM binary, but we want it statically compiled. So we do -- static, I think. Need to add a space. Then we can do file on a.out and see now that we have a static, not stripped, and that's what we care about. Is the fact that it's not stripped, we'll have a bunch of file names and be able to use in there. So I don't need this since that was the correct library or correct package. So we can toss in a.out, I think. Let's see if I'm remembering how to do this. I'm going to make this, didn't even make that bigger. What we want to do is then do emulator version tracking code browser. I think version tracking. Let's open a version tracking on a.out. Don't care about that. We're going to open a new session. New session name, we can just say analysis. So the source program will be a.out and the destination program will be agent, and this will allow us to identify any functions that look similar between the two. Sure, we'll run the precondition checks. There's some stuff that it doesn't like. Number of functions with signatures and decompiler parameter ID with analyzer 0. So it's just saying both binaries have some functions that don't exist within each other, so it kind of looks odd, but that's all right. Go to next, finish. We'll analyze that, because, that actually probably should have been done first. What's going to happen is it's going to open up two windows then. I'm not sure. Probably have to wait for that to finish. So maybe we should have analyzed it first before we went through all this. But that's okay. Should maybe save the other one too. Something error other than don't matter too much. Let's go and run the correlator. So now it's going to go through and kind of correlate the functions. And it looks like we have a couple of matches by implied match, duplicate functions, all of that stuff. Is there a way to just say all of them? So probably not the best way to do this is to highlight them all and just say except. But I'm going to do it anyways. And if we then click all of them again and do apply markup, I think we should then come over to this one. So this one should be agent. Check out the functions which are currently missing. I don't ever remember how to get those back. Tools, navigation graph analysis. Is it in here? Simple tree, symbol references, memory map. Function graph, don't care about that. Display listing. I might just save it and open up the other one then. I think that's all we wanted. It looks like we have some markup implied. I think everything should be good to go if it correctly sets the function names and variables throughout. Let's just grab these all again and try that. Let's do it again. Oh, maybe it's only highlighting a couple at a time, or a certain amount, because it looks like it's not grabbing them all. It looks like we're starting to run into errors, but accept matches invalid memory address. That's probably just trying to get down to variable names at that point, and that's fine because we don't really care about. We would like these ones to be matched if that's possible. Oh, yep. So it looks like if we come over here, we can see that all of these functions now have function names associated with them. So if we were to run across them, it should correctly identify them in our binary. And I think if we save all of those, close it, and we open agent back up, got a big one right now, and we go back to main, go back to this looping function, or this main function. Looks like we have exit here, sigproc mask, so it looks like a lot of the functions did come in. So it's perfect. So now we don't need to worry about trying to identify all the functions, as we have a better understanding of what's already here now. It's not perfect, as any of this ever will be, but it's a start. So then we can actually start looking through, and we just have random calls to free, which may or may not be correct. If they are, it's just not identifying any parameters passed into them. But I think most of these should be correct. But yeah, now we just need to identify the few that remain, which I might miss. I'm noticing that I missed a couple important functions, and that has to do with the way I compiled it. So going through this, we can realize that I'm going to close this real quick. Might even just delete these two. Hopefully that doesn't break anything. If we remember back to our config file, when we ran it, there was this daemonize variable, and that usually hints at some kind of threading or use case. So I think if we just run strings on agent and grep for pthread, we can see that there are pthread structures and pthread instances, and that's what we forgot. And that's kind of a big library. You want to try and get all the side libraries, or as many libraries as you can, and pthread is a big one, because if there's any function that do threading, you don't want to have to go through those weeds and dig into those, as they can be very cumbersome and hard to identify. So let's modify this one a little bit. We'll just include pthread.h. Hopefully this just works right out of the box, because I'm not sure how dash lpthread. Might have to Google that. Oh, it appeared to work. Grep for pthread. Awesome. So now our a.out has pthread stuff too. So if we re-toss this guy back into Ghidra, a.out, where you at? There you are. Then we'll just go through the version control again. Start up a new version control. We'll call this analysis again. Source program is a.out. Destination program is agent. Going to next. Running preconditions, I don't think it matters too much. Finish, because we got to do the analysis for a.out again anyways. Get this analysis going. Let this run for a little bit. There's a lot more functions now this time, as we had added the pthread, and it should still be static, I hope, because if it's not, we're going to have problems. We'll have to run this one more time, but it should be good. Just messed up on some dwarf stuff. It's weird that version 5 was detected, but that's okay. Let's go into the correlator. So by default, there's a magic correlator that'll just do 8 default correlations. There's, I think, a couple more that you can add, but it's not really needed. So let's just highlight them all, accept them all. Some of them should be already good, since we already have those names. But what we want is anything that's pthread related. Sure, we'll accept that. except it says the exact symbol, but yeah, it's not updating. Oh well. So it says we have pthread types in here now, so that might be enough to say that it all worked. Let's close it and I check to see if it did. Check out agent. What we're interested in is just check to see if these functions now include pthread functions. We can see that on the side we have a bunch more functions now, and look, we have pthread functions. And if we come over to, oops, I didn't want you to snap, but whatever. If we come over here, I was hoping it would identify a couple more pthread functions. Let's go back into the analysis and see if we can't get a couple more. There's a couple on that main front that we definitely want identified. Might just be not working because it might not be included, as I didn't include any pthread functionality within a.out. But it's identifying some of these. A.out has it. It's identifying it there. Let's just look up a pthread C example and just run that. Pthread C example. Sorry. We'll just copy this guy. Vim test.c. We'll just delete everything. Unisted.h isn't a bad idea to include. Sometimes the more functions you include in the original binary, the better off you are at identifying. So the fact that we're doing a pthread create and join might make it better to identify those functions. Arch, do that. Let's come over to Ghidra. We're going to have to run this analysis one more time. So we'll just delete those. It might not hurt to just delete agent as well and redo that one, as agent has also been modified since the first one, so maybe the naming schemes are going to be throwing each other off since it's going to have names and it's going to try to overwrite names several times. Doesn't hurt since we haven't actually modified anything within there yet besides the main function. So now we have a.out and agent. We can create a new analysis. This hopefully for the final time. Oops. A.out. Agent. Next. Run preconditions that shouldn't matter since we don't have anything analyzed between either of the files. Analyze both, please. So it should take a couple seconds to analyze both of these. But once that's done, see down here when that's done spinning. When that's done, we should be able to finally, hopefully, get a match between a lot of the functions within the binaries. Shouldn't take too long as both the binaries aren't that large, but since they're both static, they're going to have a good number of functions within them. Looks like agent's taking a little bit longer. While this is going, it wouldn't hurt to just toss in the diagonal client into Ghidra. Wherever Ghidra went. Diagonal client and maybe drop her as well. Can maybe start the analysis on those because those will also have to be analyzed. Looks like that's still running, so we can just start diagonal client. Analyze, yes please. A lot of those parameters usually don't need to change. You can make it more aggressive or less aggressive if you want. We just let that one run in the background. Is this guy done yet? Agent looks to be. So now we can do the analysis magic. See if there's any correlations. Looks like we got a couple functions as we should. Just accept them all. We'll just accept them all again. Details. Errors encountered for accept task. Invalid memory address. Stack. It's weird that it's trying to name a stack address, but that could be because I added the debug symbols. As long as a lot of these are added, which I'm going to sort by the name of the source and check for the pthread functions because that's kind of the ones we care about right now. So pthread kill. mutex once self pthread join. Those ones should be identified. Not noticing pthread start or whatever it was called. What was it called? Get test.c pthread create. For some reason, I'm not identifying that one over here. But that might be okay. Pthread ID, pthread create, pthread join. If we have a join, we should be able to walk it back and follow the ID and still identify it. So that should be good enough. I think we should be able to close this now. Save those. Open up agent. Dropper should be finishing up. If it hasn't already, it has, so we'll just close that because we don't really need that running right now. We just wanted to get it analyzed. We'll analyze the client one as later. Please open. There we go. So let's go back to entry because now our main is gone. If you're ever looking for main, it's usually always the first lib or first function within entry. Not the first function, but the first parameter within the first function, because the first function will always be, or should always be libstart main unless they modified it to be something custom. Let's come here. Doesn't look like it's set it as a function. This also could just be a intermediary handler because it's all doing is jumping to another function. And this will probably be our actual main. We can rename that with the L button hotkeys, or you could right click it. Looks like not much else changed. We did find some pthread joins, which we're hoping for. There's no pthread creates, which should have been identified, but that's all right. We'll try to identify pthread creates first, as if there's pthread joins, there's definitely going to be creates. So we can see that we have these two variables here. It's really hard to identify it or see it probably in the video, but they're getting highlighted up here as well. So this one is the same as this one down here. So we probably set those to a name like thread 1 or something. Set this one to thread 2. And as we know, thread 1 and 2 are coming into this guy. That means that this right here is probably going to be pthread create. And we can identify this based on the signature, because it's going to have thread ID, null of some sort, a function, and then parameters. In this case, there was no parameters. Here we can see we have a thread ID, 0, which is null, a function, and then parameters of some sort. So these are very characteristic. This function is very characteristic of what a pthread would be. Looks like we have another thread ID here, so we do thread 3 even. And I think this one gets finished down here at the bottom in this join. So it looks like it joins after all these other ones. Looking through, we can then try to identify other miscellaneous functions. So maybe something like this. It looks like we're printing to standard error, one of some sort, a string, and then a parameter. So maybe this is going to be fprintf or fprintf or something. Doesn't really matter. It just looks like a format string function. That's all that kind of matters. This looks like we're going through after an error. We're hitting this one parameter, so this is most likely just the exit function, and it looks like it happens within every error kind of thing. So subroutine doesn't return. Good chance it's probably just an exit. We have these functions here. It looks like they're all the same. No, this one's A0. This one's D0. A0. If we just look through it, doesn't look too impressive. Does some MRS stuff, which off the top of my head, I don't know what that means, so we're just going to ignore it. Same with this one. Looks like MRS stuff. So maybe those functions aren't important. Maybe we can step through them later in GDB and identify them. Looks like we have two real functions here. SVC is kind of the system call equivalent within ARM. 4a, I don't know what that is off the top of my head, so maybe we'll do Linux syscall table. I think Chromium is a good one. Has ARM. We can go down to the 64-bit version. We're looking for 4a. ARM syscalls are sent in through the X8 register, so we're going to look for 4a. And we can see 4a is going to be signal fd4. I don't know what that's for, so maybe we just say this is the signal function. Doesn't have to be anything spectacular. We can just put temporary names there for now. We have another function here. Looks like it calls an internal function if a parameter exists. Something else happens. At this point, I might be getting too far into the weeds, so I'm not going to analyze that function in depth because we don't probably care too much, as kind of the main focus that we'll probably get to later on is the threading functions, as that's where a lot of the meat will probably occur. You just assume that based on the thread creation and that they're threads in general. So maybe these are just kind of setup functions. Could not resolve config path, pointer to standard error. This might just be another printf that prints specially, so fprintf again, just printing to standard error, so maybe it's even fputs or something. We have two functions here. Looks like this one's setting up some kind of parameter. Opens up this function. Not seeing any system calls right off the top, so I can't really name it to anything. Looks like we have a calc, so it's creating some kind of structure, setting some variables in memory, setting a function pointer even in memory. Function pointer doesn't have anything of use that we can identify yet. One more function we can identify. Looks like it's just freeing data, so still nothing. So maybe we might say it looks maybe kind of like it's setting up a structure. We don't know what kind of structure, so maybe we'll just put a question mark. We could tell Ghidra to auto create a structure for us, but sometimes that causes more harm than good, because now then we might try to work with that structure only and it could cause problems. And here we have a file IO error if we're doing something here. So we could check out this function, tries to call this function. IOW file writes, so maybe you're trying to set something up. Maybe this is just since there's an fstat here that implies that some kind of file is trying to be opened. So maybe this is open, and it just didn't identify it within the compilation or the characterization. We'll start to get to some interesting stuff down here when we try to see the words daemonize and log level and restart flag, SSH private key, and we start to realize that we've seen a lot of those strings before in the config. So a lot of these look very similar to just straight up what the config has, so there's a good chance that this function itself is probably trying to load config, so load a variable from the config. We can try to then, we can look into it to make sure that's actually what's happening. It doesn't look like much is happening within here, so maybe it tries to read a file, or it's just comparing data this entire time. If we go back, we're just going to go off the assumption just based on these names that it's probably going to load the file into memory, or it's loading these variables in memory. We can see that it's passing in these variables as well, and these variables are then being compared shortly after they're created. Not the log level, but daemonize is being compared, and then it's going to call this function if it is. Restart flag doesn't care apparently. SSH private key. So this second variable is probably where it's being stored. So we could rename all of these variables if we want. And then this first one seems to be shared across all of them. So there's a good chance this is probably our log or our config file itself. So we can rename that. Might as well. Looks like there's a different kind of configs that are being loaded. So daemonize has a different one compared to log level, which maybe holds up to the fact that log level is just a number, whereas this is a boolean and these are strings, boolean. So let's look for command port and see if that theory holds. So command port does load config, and load config is the same as log level, and so far those are the only ones named, so there's a good chance that's actually load config int, so it's just loading an integer from the config. If we look back, let's look for a string, so ID file here, so this one's probably load config string, and it looks like the majority of them are also that. Is daemonize different? It looks to be, so that one's probably load config boolean. It looks like we have two more, or a couple more still. This one appears to be a list, or an array or some sort. So load config could be even JSON, because we don't really care about that one as much, so that doesn't really matter. There's a couple of functions in here that we still don't have. We could probably follow those through. So let's start towards the top. So we load a config string. It's a config from config file into here. And then we have this function on log file. So this is probably our login. This is probably setting up logging. Don't really need to analyze it any further because there's a good chance that that's all it's doing. It's getting set down here as well, so maybe it's not doing that. We can see that this data points are actually slightly different, so maybe there's a just say set memory. So maybe it's loading the value into memory just at that address. It looks like there's an A there right now. So after log file, there's an A. Not sure what that means. Whatever gets returned is then passed into this function. And does this hold true for the second one down here as well? It doesn't appear to be. So ivar5 into 12a4 also appears to be the... Oh, this is log file. So that's not set memory, that's set file. It's weird that possibly restart flag is also using that, so maybe it's actually setting something in memory still. And then this might be setting the actual logging with the actual log file. So this might be creating a structure of some sort, which setting values in memory. So there's a good chance that this is our logging structure. Nothing to really concern ourselves with, but set up logging. We have this other file if logging fails. Logging shouldn't fail, but it looks like it just sets it to whatever parameter is sent in. So maybe it's just set to memory no matter what. Load config string, it loads the restart flag. So that should be a file as well. Yep, because restart flag, if you remember, restart flag, where you at, is a file. So that makes sense. Set the file, whatever this guy does something. Not too important, probably. Looks like we have another structure created. Another function that's just calling calc, kind of not needed, but create some kind of structure. Create struct. U7 is then passed in somewhere, nowhere. I'm not sure. We have a private key, and then right after the private key, we have another file called with this guy. So there's a good chance that this is just reading the private key. So read priv key. We have an interesting setup here, but based on the fact that it's in blocks of 4, and it kind of looks like it's rotating them, this is probably just converting from little endian to big endian, or just doing kind of blocks of 4 within the setup. Key file, navigate, blah, blah, blah. Looks like we grab the dropper exe, dropper config, dropper dir, store those into these guys. These ones might be important to follow at some point, as they're a unique set of function names, actually. And then we come down to pthread creates some kind of string. This might just be a wait or just a printf. Looks like it's calling fprintf. And then there's a while true, so maybe it's just logging, or just the wait. Wait for finish, we'll call it. Wait for finish free. A lot of these functions down here probably don't care to us. It looks like it's just zeroing out memory and then cleaning stuff up. So with that, we have the majority of these functions all kind of named. We're still missing these ones, but there's a good chance they don't matter as much. So now we could probably start to hop into the threads. We could try and follow the variables and see what variables are set up and passed into each one. But at the moment, we're going to pass on that, as it appears a lot of them kind of just share the same naming scheme anyways. Might be able to just auto-create structures here as well, because it appears they're all the same, or kind of similar setups. So we'll jump into the first one. So it looks like the first one just right off the bat saying starting upload thread, so we'll just call this one upload thread. Let's see if the other ones are named real quick, just to make it easier. Starting collect thread. Collect thread. And then this next one, we'll say the command thread. And that should be it for the naming of these. I'm going to save this file real quick so in case we lose anything. And I think with the length of this video, I'm going to split this up into 2 parts. So I think this will be the end of part 1, and then the end of part 2, or the next part, we'll start diving further into the upload threads. So yeah, thanks for watching.